छुट्टी हुई थी पहले से ही।
मैं सोचा रिया जैसी मंगा भी कर रिया क्या तो बिल में नहीं है।
यहाँ मेरे को रिया जैसी तो जवानी है
1100 की है उसकी।
अब।
हाँ अब क्या पहले भी उसकी महंगी होंगी।
कौन कह रहा है इतनी महंगी तो नहीं होनी चाहिए यार।
क्योंकि मेरी मम्मी पहनती है ना बाटा की चप्पल 600-700 की नॉर्मल चप्पल आती है बाटा की।
Hitesh, am I audible? Audible? Okay, so good morning, everyone. So I hope all of you have downloaded the day 2 folder. So first we will see some plots, plots, then followed by start with computing, peak analysis, and then basic. These four are the for today's content. So last day we have discussed a problem, and then we have for group indexing. So we'll start from there. So the problem was we have considered three different states, and the voting counts of three different states and last three different days. Okay, so we consider if you see the data here, so consider three different states: Delhi, Assam, and UP. Last three general election, 2019, 14, and 9. Okay, this is the numbers: male voters, female voters, and non-eligible for voting. The problems. So, see, when you open the plotting files, and there you select, you click on the group index. So I have three different folders here. So you click on the group index. Okay. So then there will be one additional sheet will be there. I guess you can delete that one. Go to the sheet one. Okay, so this is the problem. Now you see, now previously, for example, now when you discuss the time versus efficiency graph. So here what happened, there was one category was there. We have X and Y axis, and in Y axis we have three different models. So three different models, that is my one category. Now here category, it means that like my data points, these are not text, numbers. Here you see the stage is not my number. And also the year, general elections year 2009, 14, and 20, and these are also not my numbers. Then the category of voters, male voters, female voters, and then the non-registered. These are also not my number. So these four categories. Now, so you have three categories. Previously, you used to have one category, now you have three categories. So for this type of data, what you can do, there is one option, index plotting. So if you see the plotting part, if you click on the plot, then under plot you have categorical. Then here you will find that group index, grouped column index data. So you have here you have more than one index data. If you have more than one index data, so that the plotting will be under the group index or group column for index data or group line index data. So now I have the index data here, right? So all of you have got this file. Okay, shall I continue? Okay, so let's plot this. Select this whole workspace and then plot. Then under categorical themes, then you have group column index data. Okay, so see, sorry, you just need to select the datas only. Okay, yeah. Click on the group index, the first row. Origin flags, you just double click on the plotting. Just double click on the plotting of origin. It is the origin files. Just double click on that. You don't need to import it. Its data is already imported and it's the origin file. So just double click on that. Don't need to import those files. You just double click on the plotting file. All the four files are the origin file only. I have already imported data in that. So you just double click on that. So now then if your project explorer is coming on the left side like this way, see here in the screen, if it is coming in this way, click on that and then click in the drop down button and click on the deselect, disable the auto hiding. Okay, so now let's see. Now you need to just select the data column only. So when you are doing the group index, you just select the data column. So here are my data columns. The C, D, and E is my data. Yeah. So then plot, categoricals, group index. Now a windows will pop up. So these are my data. So C, from C to E is my data columns. If you see here, C2 is my data columns. I need to select the group, which are the group columns. So now I have how many group columns? One group column is already there with the data, right? The categories of voter, male voters, female voters, and not eligible. Now I have two more group columns, right? Two more category. So for that, the group columns here. So you click on that group. So you have AX and ABY. AX and Y is my two group column, right? First group column AX, then second group column AB. Okay. Then click on the preview. Now you can see the graph preview how it looks like. You just see the notes. Don't look at the legend now. So you see now I have three different years for all the states: Delhi, Assam, and UP. Now let's say you want the states at the top, then at the bottom. For example, you want to compare the year-wise election-wise the state vote percentage. Now here it is for a particular state, you are comparing for a particular state for three different general elections. But if you want to do that alternatively, like for a particular general elections, how the state voters are percentages are varying. Okay, so for doing that, you just need to change the group column. So the first here I have select sheet A, that is my Delhi, and the states. Then I have the general elections. Now you need to just reshuffle it. Okay, you need to rearrange it. For that, so if you select it, now I want my the states at the top. So here you have it move up. So once I move it, again click on preview. Now you see it is now for a particular general elections, you are comparing for a particular general elections how the numbers are varying for three different states. Okay. So as per your requirements, you can reshuffle your columns and the legend. So then click on OK. Now you have your plot. You see here the legend. What the legend should be? The legend here is the state, but the legend should be as per the category of voter. What I want now, the legend is the category of voter. Why it's not coming? Because of that the color. If you see the color for Delhi, for example, for Delhi, if you see the color for three different categories, the color is same, right? So now because of that, you are not getting the legend as the category of voters. So click on any of the color, any of the columns, and then in field columns, then you will find in field columns edit mode dependent. Make it a dependent edit mode. Don't change the edit mode. Make it as a dependent. Then click on by one. What does it mean? That I have selected the first column, right? The first column for Delhi. So for Delhi, I am giving a single color. For Delhi, now I am giving a single color. So that accordingly now you are Delhi giving a single color. ऑन तो है ऑन तो है पीछे So now for state Delhi, let's say for state Delhi, now I'm giving a single color. Click on apply. Now you see for different categories you have different color, right? Okay. Click on OK, and then you just reconstruct your reconstruct your legend. So you see again, I'm repeating it. So I have data columns. My data columns are C, D, and E. So now select the data columns first, then go to the plot. Categoricals, under categoricals, you will have group column index. The group column index, select on group column index. Then my data points are already selected here. Then now you need to select the index. The index I have AX and BY is my index. So for selecting the group columns, click on here. So first step selected AX, then BY. Okay, AX. Now preview it. Now you see what you want. So if you want a comparison based on state, for a particular state, so then you can keep it here. And if you want to compare it based on the in a particular general election, how the state voter counts are varying, so then you can move the columns here, the group columns. So for doing that, now you just click on there, move up, then click on preview. Now you see that it has changes, right? Okay. So now here instead of the voters category, in the legend I have the year general election year. That because if you see for a particular general elections, let's say 2009, so all the categorical voter, that's male voter, female voter, and then not eligible. So these are in a single color. So what I have to do, I have to change the color code. So to do that, you click on any of the bin, and then make and changes the field color from none to by one. Okay, so by one means that I have clicked on this. The first one is the male voter count. So for all the male voter counts, male voter column, I am giving a single color. So similarly, automatically, then for all the female voters, there will be a single color. For all the not eligible, there will be a single color. So I'll have in that case, I'll have different color coding for different categories of voters. Okay. Now you need to reconstruct your legend. Click on this and then click on this reconstruct legend. Now let's change. Let into some formatted data. So let us first the feed layer to the page. I have 0.5. Now, if you don't want the table, below that is the table is there. If you don't want the border, so then you can change those borders. If you don't want it, if you want it, you can keep it as it is. Now, let's say you don't want the border, then also you can change it. So for that. So after this is clear. So now let's again go to the axis properties. Now, if you go to in the axis properties, if you go to the tick level, now you see here you have two bottom axes, bottom one and bottom two. You have two bottom axes because like if you see that there is you have two bottom axes. One is state and one is the general election. So general election.
So you are not audible.
Yeah, am I audible now?
Yes, sir.
So under table format, if you look at the bottoms here, tables, under tables. Now if you look here, you have different different border boundary. So whether you want to enable it or disable it, it's up to you. If you don't want any borders, so what you can do, so bottom one means at the extreme bottom. Here the bottom one is just extreme bottom. So if you change it, let's say we don't want any borders from the bottom one. Now you see, do not have any borders. So other things that you can change it as per your requirements, like the text and all these things. So that I have already discussed yesterday how to do that. So I'm not going to that. In the second graphs, let's say if you see the Assam, that is like it is not completely showing. So first you feed the page, and then go to this axis. So if it is not fitting there, so instead of it is in that, you can rotate your text. So you rotate your text. For example, if you rotate it for 45 degrees, so now it is relatively visible. You can rotate it for 90 degree also. So if your text is if there is a like if you have a long text, so you can rotate your text. You have the option to rotate in degrees, 0, 40, 180, whatever extents you want. And your wrap text will work only if you have more than one word. Now you have only single word, right? So wrap text here will not work. Then click on the feed page again, because so you can change it, because it automatically, once you change in one, either bottom one or two, so default setting is auto. That is like it will change to your bottom, both the bottom axis. So if you don't want that for the bottom one, if you don't want to rotate it. So you can change it by going to the bottom two in the bottom axis.
So any doubt on group indexing? So is it clear now? Group indexed. So next, let's go to the insert. So click on the insert folder.
So insert is basically when you have one graph, inside the graph you want to plot one more graph inside the graph. Okay. So this you may require, for example, you have some the calibration data. So we want to show the calibration data inside your graph. You have some graph, for example, like those who are working with the UV spectrum, you have to do some first you have to do some calibration. So the calibration graph, you have to show it in the calibration graph. So that calibration graph you can give it to the inside of your original graph. So or else, let's say you are doing some comparison study. So at some point there is like most of the changes, the differentiators are there in some particular region. So that you want to highlight that region, so that region also you can zoom it and insert it inside your original graph. Okay.
So here for that I have data for three different models. I have porosity versus pressure data for three different models. Okay, so you just consider it as a data. What porosity pressures you don't just let's forget about it. So if I plot it first, make it as a spline plot. Make it as a spline plot. So if you see this is my plot. Now, if you see in this region, there is some similarity between the models. Some similarity is there in that model. So I want to zoom this part. These sections I want to zoom these sections, and keep it as an inside the original graphs. This part. So what you have to do, you just duplicate the original graph so that my graph is the original graph. Right click on it, duplicate this graph. Now I have two graphs here. I have two graphs here, the same two graphs. So in these graphs, you make some changes in this graph. So you see the axis, the length of the axis, in which part you want to zoom it. In x-axis, let's say I want to zoom it in x-axis 0.5 to 0.55, and y-axis the value is corresponding value in y-axis will be around 3 to 4 to power minus 9, right? So for doing that, so you just need to now for in this plot you just need to change your axis range. Okay, for axis range the bottom scale, so I want it from 0.5 to 0.55. Similarly for vertical, let's say it's from 3 to 4. 3 into 10 power minus 9 to 4 into 10 power minus 9. Now you see a particular I have porosity from 0.5 to 0.55, and in that regions the value is 3 to 10 power minus 9 to 4.10 power minus 9. So to now as an inset, what you have to do, just copies this graph, then paste it. Now adjust its size. Okay.
सर एक बार ये वाला ग्राफ दोबारा से रिपीट कर दो.
So just for example, I'm again repeating it. So first I'm plotting this one. Drag this to here. Okay, then duplicate these graphs. So this is graph 5 is my current graph, so duplicate it. So now I want to zoom these sections. Let's say these sections I want to zoom for x-axis 0.5 to 0.55. Then corresponding values for y-axis, let's say it's 3 into 10 power minus 9 to 4 into 10 power minus 9. To make some changes in this duplicate graphs. Change the axis only here. So axis, so scale from bottom, so I want 0.5 to 0.55. Vertical is 3 e minus 9 to 4 e minus 9. So now I have the zoomed view of the graph. So the click copy this graph, then paste it to the original graph. So now I have this pasted graph here. So now you just need to resize it to fit it inside the graph. And rest of the formattings, that the text format, the thickness of the lines and all these things you can do. So this one is for portion of your graph. Now you can do it for two different you can give it inside to a separate graph also. Don't need you not necessarily you only can give only the zoom view of your. So whatever graph you want to give it an inside, just copy it. It can be, for example, if you want to give insert in some images, that also you can do it. You just insert an image and paste it to the graph. Okay. Anything you can give it if you click on the insert options. So here in the insert options, you have separate you have image from file, image from Windows, or image from web. So that you just import your image, and then that image you give it as an insert. Anything you can give it as an insert. So whether it's a zoom view or it can be a new graph, it can be image. Okay, but it can be an equation itself. You just write it as a text on equations, but you have to write it in LaTeX language. So LaTeX language. The equations are mostly in LaTeX language. So that you can give it as an insert. Or else you write your equation somewhere else, and from that you can copy and paste it. Next is, now let's say you have 4 to 5 graphs. You have 4 to 5 graphs. You want to mark it in a graph with A, B, C, D. Okay, so mostly what I do, you just do it in PowerPoint or in Word itself. You are just giving it to different columns. So 2 row 2 columns, 4 graph, 2 row 2 by 2, and that we give it. Now you can do it in the origin itself. If you have 4 graphs, you can mark it in origin itself. So for that, so let's go to the March graphs. Now I have four set of data, so I'm just creating 4 different plots for that. So you might get an error if you are the number of integers are exceeding more than 10. So you have to delete some previous graph. Okay, if you are considering the student regressions. If you are using three student regressions, you cannot have a window. We have in a project, you cannot have a window more than 10. Okay, so if that error is arises, you just delete your some previous graph. So now here I have four different graphs here, right? So I want it as an A, B, C, D in a single graph. Okay. So if you click on that, click on graph tabs, you have two options. You see merge graph to layout and then merge graph to windows. Merge graph to layout is a default setting where you have to select your number of graphs. Based on the number of graphs, origin will give you some layout and that they'll feed it in for some layout. It's a default setting. Okay, you won't be able to change the like spacing of your the spacing between your two graphs or the vertical horizontal spacing between two graphs. But if you want to customize your the plotting based on your requirement, so you do merge on the Windows basis. Merge graphs Windows. Okay, so if you click on the merge graph Windows, here automatically the active graphs, I have the four active graphs here. So it has taken as automatically as an 4 graphs. If you see the graphs, graph 7, 7, 8, 9, and 3, it has selected automatically. Now, if you don't want it, for example, so you don't want all the 4 graphs or all the active graphs here, so you select that graph and you can remove it from here. Now, if you want to change the so let's say the preview here. So this is the preview. So if you want to change the orientation also, let's say you don't now I have model A, B, that A, B, C, D. So if you want to change the orientation, here you just either it move up or move down. So for example, if I'm moving the 7 as down, so you see the orientation has changes, B, C, D, then A. So accordingly, like based on your requirements and the whatever the orientations you want, you can change it. Now others is the arrange settings. So since I have 4 graphs, it has a default automatically. It has detected 4 graphs here. So it has taken 2 by 2. Instead of 2 by 2, let's say if you want like I think the portrait mode, so then you have 4. Right. So based on this orientation, your orientation requirements, you can change the number of rows and number of columns. So let's say like I want it stacked in a portrait. So my number of columns will be 1 and number of rows will be 4. If you preview it, you see all the graphs are stacked in is stacked. So let's keep it 2 by 2 only. So here I have now one more orientation. Orientation is that I have A, then right side B. Instead of that, if you want A, then B at the bottom. So after A, then at the bottom B, then C, then D. So that the directions you need to change the direction from horizontal first to vertical first. So you can play with all these options on this drop down menu and see the preview how it's changing, and accordingly you can set your parameters. So if I select horizontal, the direction here is horizontal first, right? So horizontal first means your first two graphs, first two graphs A, B will be first horizontal column, and then the second horizontal B, C. So instead of if it is the vertical first, then A, B, then C, D. Okay. So if I select the vertical first, you see vertical first preview. Now you have A, B, C, D. Rest is not that important here. Now that's coming to spacing. So here spacings, you change the spacing unit. It's a percentage of page or others different units. So I'll suggest to don't give it a percentage of page. Instead, you give it as an inch, centimeter, or some unit. Okay. So let's say I'm taking the centimeter. Now then centimeter. So if you want to reduce your space or if you want to reduce your borders, you can do it from here itself. So you have right margin, left margins, all these margins are there. So if you want to change the margins, so you can do it from here. So let's say I want to increase the vertical gap. So the vertical gaps have kept as a 2. So you have the vertical gaps are increased. So again horizontal gap as well. So then if you can change the margin here itself, you can change the margin. So let's keep it all the margins as 1. Clear up to this? So one more important setting here at the tops, you see you have an option keep source graph. That keep source graph is enabled now. So like if you disable it, keep source graph, then what happens, your graph will rearrange to the new window and your automatically original generated your previous source graph. If you want to previous intake, so this option keep source graph. Otherwise, it will automatically originally delete your other four graphs or whatever the number of graphs that you have merged it to the windows. Okay, so there's this option you should enable it if you want your source graphs intake. So let's click on OK. Now you see I have this. This is the arrange graph, and this all these graphs, 4 graphs are intake. Now the interesting part is here. Now if you are making any changes to your the source graph, my source graph, any changes you are making in source graph, automatically the change will reflect to your arrange graph. Whatever changes you are making, you don't need to change it. You don't need to mark it changes. If you are, for example, let's say you have deleted your source graph,
you have the merge graph. Then also, if you are changing something on your data, that changes will reflect to your graph. Okay. So if you don't need your graph separately, you can like delete the source graph, but the changes, whatever changes you will be making, you are making to your data, same changes will be there to the your rearrange graph or something.
So after this is clear?
Any doubt?
Sir, please tell again, keep source graph option. Why is it important?
Okay, so source graphs is like, if you are, for example, let's say for example, I'm changing some things to the this graph, my graph 3. Let's say I am changing the thickness of the line here. I have changes some made some changes changes the thickness of the line. So sorry, not this one. So let's say instead of the model D, I have it as the model F. It's the model F. So then this one. You see here the changes, whatever the changes I have made to the data. So that similar changes are there in that in my the rearrange graph also. So if you are making any changes to the data, so then same changes it will reflect to the your rearrange. You need to rearrange it again. Okay, so we'll move to the next section. So now we'll start the curve fittings and peak analysis. Go to the data that I have sent. So in that you have peak and the curve fittings. Open the curve fittings graph. Just double click on this curve fitting. So in curve fittings, first we will discuss the linear fittings and then non-linear fittings. So basically, curve fitting is that you have some discrete data, so that you are doing you will be doing some regression. After regressions, you are the fitting a model. For example, you have some X and Y. From that X and Y, you have the mathematical model. So y equal to something of X. And it can be linear y equal to mx plus c. If it's linear, it will be mx plus c. If it is exponential, y equal to some constant a into e to the power minus bx. So these two are so and same things. If you want to calculate the parameters, for example, for linear y equal to mx plus c, you have two parameters here.
So one is m, the slope, and the intercept. C is the intercept. So that you have x and y linear data. So after fitting the linear, from the linear fitting, from linear regression, basically it's a regression. Linear regressions, you are calculating that m and c, right? In the slope and the intercept. So say if it is exponential graph y equal to a into e to the power minus bx or a into e to the power bx, so you can give the parameter from for calculating the parameter. Just it's a mathematical model, right? So we have one linear, one non-linear. In there are a lot of the models, inbuilt models are there, inbuilt equations are there. The like, basic equations are already there in origin. Now, if again there you have an options to define your user defined equation. If you have some particular equation that you want to fit you want to model fit your data, so that also you can do it from the user defined equation. You can define your equations and accordingly, and that you can fit your data. So I will show you three examples here. First, linear and non-linear, which is already there in the origin, and one is that customized equations. So first, let's start with the linear fitting. So here in linear fittings, I have data x and y data. So if we plot this data, see this data is a bit of noisy data, right? It's a bit of noisy data. If you do it a scattered plot, so the data are some like it is not a fitted not a straight line, but you can fit as a linear fit. Now if I want to fit it as a linear fit, that y equal to mx plus c. So what you have to do, you just go to the analysis. There you have fitting. Under analysis tabs, you have fitting options. You have linear, fit linear with x errors, polynomial fit, non-linear curve fitting. So to linear fit. Sorry, you can define your data from there. So the range. So this x and y data is my range. X and y, both the data is required. X and y. Click OK. So linear fit is easier. So you see all this data. If you click on that, you have y equal to a plus bx. Your a is your intercept. So you have the intercept value. A is your intercept and b is the slope. So your intercept and b both will have with standard deviation. The value will have the value with standard deviation. You see a some values plus minus your standard deviation. B some values plus minus standard deviation. So select the data, analysis, fitting, then linear fit. So these are data is already selected here. So these are the data here. Click on OK. Now you have several plots also here. You see the plots of fitted y and of the residual errors in terms of x and in terms of y. The fitted graphs and then the number of counts, number of data counts also. So now few more options.
See, now is previously what I have done, whatever the default setting that origin has, I have just selected the default settings. Now here you can change some parameters. So let's say fit control. So if you're if for example you have equation y equal to mx plus c, but from that you know the intercept. You know the intercept. For example, you instead of y equal to mx plus c, you want only y equal to mx. Your intercept is c equal to 0. You have all the data you have y equal to x data. You have y equal to mx data you have. So from that, what you have to do, you can fix your intercept. The fixed intercept at if you enable this fixed intercept, so then you enter your intercept values. Yeah. Same things you can do it for slope. So for now, if you know your slope and you want to fix your slope in for certain values, so you can do that for that fixed slope, fixed intercept. If you give the fixed intercept at, then you can give the values here. Same things for fixed slopes, you can give the values in the fixed slope. So now these are some fitting parameters which you like for your models. Which are the parameters that are important, which you want to do. For example, for t-test you want to whether you want to adjust an r square value or r square value. So based on the parameters you can enable or disable it. Okay, so these are some parameters. Actually, these are the fitting parameters to interpret your models, whether your models are best fitted or not. Whether you should go to other models. So based on these parameters, fitting parameters, you can identify your fittings. So residual analysis, here are residual. So the different kinds of residual analysis there. So mostly regular is using the output, how output should look like. So this, let's keep it as a default. The fitted curve plots, keep it as default. Find x, y, find x from y, find y from x. So this find x from now, once you fitted your data, like for example, so you have fitted your data y equal to mx plus c. You know now you have for m and c. The original fit your data y equal to mx plus c, then you will find out m and c. So after fitting, now let's say you have some certain value of y and you want to calculate the corresponding x value of that your y value. So that you can do it from find x from y or find y from x from that option. Then residual plots, you have different plots. Different residual plots is there. So they can be, these are all these plots. Clear? Now more option is there. See the recalculate options. Recalculate auto, none, and manual. So it's actually now if you are changing some data points, then if you are selecting auto, then you don't need to recalculate again. So automatically the values will be changes here. So accordingly, so you can do it. So here all the parameters are there here itself, so that you can see
So how to use the option finding x from y or y from x?
that if you have some for okay. So find, you just enable it, and once you enable it, it will some of your values will be calculated from that and it will plot it like x versus y, the calculated, predicted and actual. If you are enabling it, then calculated and predicted and actual values will be calculated. Once you have some values x versus y, from that some value, some of the x values, they will calculate, the origin will calculate, and it will give you the corresponding y value, and from that they will calculate this error. What are the percentages errors are there, whatever the actual data from the actual data, and the predicted data from y equal to mx plus c. Is it clear now? Now let's go to the nonlinear fitting.
Just after we get the data, you have to keep one.
So now this I have a nonlinear data. So this is an exponential data. These are exponential data. So you have in nonlinear, you have two arc broke. One is exponential, one is the user defined. So open the exponential. So exponentials, I have two different two data. So if I plot it as a scattered plot, so these are my data. So these are relatively also the exponential data. Right? If you see the data, like the exponential fitting may work there. Exponential fitting. So we try to fit it at exponential. So since the exponential is comes under the nonlinear, so we'll be doing nonlinear fitting. So again, select those data, then analysis, fitting. Now we'll select nonlinear curve fit. Okay, the options now will be nonlinear curve fit. So here you have some steps you need to follow. Some steps. First, the category. You have different category. You see, if you have different categories, you have origin basic functions. Then you have different. All these categories are there. Conventional and exponential. You have like based on your applications. Some rheology models is there. So all these models are there. So here now we'll be doing this exponential fit, right? So from that exponentials, you select this exponential. You have exponential category. Now there you have different exponential functions. If you see here, you have different exponential functions. So if these functions are not like it's not are not fitting to your parameter, so at the bottom you will have some options: new, add, search. New is will be creating your own exponential functions, and add will be adding to the from some external sources. So if you want to now functions, you have different functions. If you want to see the format of the equations, you go to that formula. If you see the formula, so asymptotic is a minus b c power x, right? Okay, so for time being, let's say the functions I'm using the asymptotic one. So these are all the default functions that you have. Iterative algorithms, you have two algorithms. So stick to this LM models.
So which function we need to use as our data fits lot many functions?
If it is based on your models, you have to see that one with, if you don't know that, like how your models will be there, like whether it is an y equal to e to the power minus x something, a into e to the power minus x, or y equal to a plus e to the power something. So if you don't know that that actual the model, so you have to you do it on a trial and error basis. If you know the model, for example, so y equal to a into e to the power minus bx, so then you can select according to your requirements, and then from that you'll be getting a into b, the parameters, the value of a and b. Otherwise you have to do it by like try different models.
Yes, sir.
So then click on OK. Yes. So this is the fit and parameters. So if you click on this, so this is your a, b, and c. Your equations y equal to a minus b c to the power x. So you have three parameters a, b, and c. So these a, b, and c, the parameters a, b, and c is there. Now, how will you know that whether your parameter model is your models, or your models are best fitted models or not? So from the to know that, you have to see that the R square value. If you see the R square value 0.92, and 92 is and that also depends on based on your application. If the application can handle relatively large error, then 0.92 is a good value. R square value is a good value. But if the response are very sensitive response, like y equal to y and x, the relation between y and x is very sensitive, then your R square value should be higher more than 0.90. Should be more than 0.9. There are some applications where if the R square value is more than 0.7, also it is acceptable. In some machine learning models, or like mostly the R square values, if it is 0.7 also it is acceptable. But that completely depends on the application. For which applications you are picking up. If it is sensitive, then your R square value should be more than 0.9. Now, for user-defined functions, so here I have the data. So this data I want to feed it as a y equal to a into 2 to the power bx. So now my the equation, the customs equations is I want to fit it as I know the equations, how the equations will be there. I know these equations will be my equations. I need to fit it my data is y equal to a into 2 to the power bx. This is my equations. Okay, so now my aim is to calculate the a and b. From the data points, I want to calculate the parameters a and b. Okay. So same things you have to the nonlinear fittings analysis fit open dialog. Now here you see this now the equations are, it will be user defined, right? Now here it is an user defined, it will be user defined. You don't, I don't, I'm assuming that I do not have this y equal to a into e to the 2 to the power bx. I don't have this equations. So select user defined, and from functions there is no function. That because I have not created any user defined function till now in my origin. Okay. So now I will be creating my user defined functions here. This is y equal to a into 2 to the power bx. So now you are creating new one, so collect new. Now you give your function name, let's say so this is so automatically now if you are doing it once, then this equation, this user differential equations will be saved in your origin cloud. So that equations you can use it later also. So once you select your that equations will be saved as an my function in the name dot pdf, sorry, fdf. Okay. Now that this your function model, so that is explicit or implicit. So let's keep it as an for time being is explicit. So if your models are implicit, then you can fit as an implicit. Laptop. Now you have different options. A laptop, then Python functions or all these things options are there. So let's laptop expression. Select the laptop. Now you decide your dependent variables are independent variables. We have now we have here one dependent variable or one independent variable. So your it can be your independent variables and dependent variables can be more than one. Okay, if you are dealing with the multi variable, then you have to change it. Whether, for example, you have x1 and y equal to y is the function of x1 and y1. So there you have two independent variables x1 and y sorry y equal to x1 x2, function of x1 and x2. So then you have two independent variable x1 x2 and one dependent variable y. So now here in that case I have one independent variable x and one dependent variable y. But the parameters, how many parameters are there? If the function is y equal to a into 2 to the power bx, then I have two parameters a and b. Okay. So a comma b. So these are the derived parameters, so that you are deriving some parameters, so that let's keep it for time being. The constant also for time being, let's keep it. Now here you have parameters a and b. If you parameters, you have to now the function body here. So the function is a into 2 to the power bx. So a multiply 2 to the power b x will be small here. So this is the equations. Now see at the top the parameters a and b. If your parameters have if the parameters you have some range, if your a or b falls under some range, for example your a is from it should be from 0 to 1 or b should be more than 2. If there is some certain condition, so that you can define here. So you can check your equations from there. For example, my initial values of a and b is 1 1. So if I check x equal to 1, for x equal to 1, my y should give you y equal to 2. A 1 1, then 2 to the power 1 equals, it should give you 2. So you can check your equations, so you have entered your equations correctly or not. And click next. Skip it as the default setting. So now here the bounds, you can give the bounds if you have some bounds, if you or b have certain limits, if that you can give it here. Okay, so I don't know if this models have any bounds or not, so I'm skipping it. If you know the that click next. So you don't have any derived parameters, so it will be blank. Next. I don't have any user defined script. Finish. So
What is
you
this
close
user
it.
defined script?
User defined script, if you have some certain conditions or if you have certain loops, so let's teach some advanced, you will know, you won't be requiring this part, so let's keep this part. Some advanced programming. So if you are okay with the programming, then you can go through it. It's some programming part here. You have to give you some
Okay.
user defined conditions here. Okay, so now I have defined my equations. So I have my equations. If you see the formula here, some problem is there. So see, for preview, there are some issues of previews is not working here. So now let's see how the iterations will work. So if you want to see the how this iteration will work, there is you have the next iteration option. So if you see, so you see how the residuals or errors are changing. So these are your residuals errors. You see the differentiation. The red one is your fitted. The black data points are your data points. The red one is your fitted curve. Okay, so in the applications, the residual errors is changing. So that means your fittings are converging. Okay, so once you know that your fitting are converging, so then click on fit. Click OK. Now you have, this is your fitted parameters. So if we click on that, so this is the graph. So you have A and B with an R square values of 0.96, 0.97. Sorry. So if you go to the sheet, so here you will have this the fit nonlinear data set, right? So if you these are the data, these are parameter calculated parameter. This is the fitted models. If you double click on it, so the graph will appear. every iteration पे वो आजकल में reduce होते जा रहे हैं ये optimize आजकल हाँ तो इन तीनों में बेसिक और अगर मतलब फिटिंग कन्वर्ट हो रहा है मतलब आजकल में इंक्रीज होगा और जो रेसिडुअल है रेसिडुअल डिक्रीज रेसिडुअल मींस एरर तुम्हारा जो एक्चुअल वैल्यू से फिटेड एक्चुअल वैल्यू से फिटेड वैल्यू प्रेडिक्टेड वैल्यू से एरर है वो कम होता जाएगा अगर कन्वर्ट होता है कम होता जाएगा एंड आजकल में इंक्रीज हो जाएगा आजकल में रेसिडुअल So any doubt on curve fitting? So this is all about the curve fitting. Now next open the peak analysis. The peak analysis folder.
So in peak analysis will be we'll see four different things. First we'll see how your data, some monthly data, how you can smooth your data. So then we'll see the baseline correction. So if the baselines are if the baselines are not perfectly aligned, then how you can correct your baselines, like extracting the unwanted gap. Then peak finder. So for example you have a pair data. So you want to know this, like you want to index or you want to mask your the data points of every peak. So that will see you can see, and then finally calculating the area under the curve. You have the area of the curve and the full width of maximum. So that full width of this maxima that you may require to determine the lady size. I don't remember exactly.
So your sound is not coming properly.
Let's start with the smoothing. So click on that smoothing. Click on method tab. Because under smoothing you have to data points. Next are you pressure video. First of this. So these data points are like, it's not that much so noisy, not that much of noisy this data. So that you can it's acceptable. Still, let's see how if you are doing some smoothing here. So for smoothing, you need to go to analysis, then signal processing, analysis, signal processing. Okay, so you have the input data. I have already done this input data. Next, the method. In the method drop down, you have several methods. You see several methods. So I'm not going to discuss how what methods are what applications you should use this. You can see that. I'll just quickly give you just a quick preview of the two methods. The first two methods, adjust and averaging, and the second method, method. The difference in two methods. First one will indicate your shape of your feet. The second one, the LG, it will indicate the shape of the feet. These are the shape. So if you want to detect the shape of the feet, then you should use the second method, LG. So number of window and the polynomial orders you can decide after seeing the preview. If you see the preview, so here, so the red one is the smooth curve. So you see it's not that smooth. Still there is some noises there. So you increase the number of points from 5 to 50. Now it's more. Now it's like some like the smoothing is there. You can see the shape of the peaks intact here. So instead, now see the difference. If I'm using SG method, the shape of the peak is intact here. The shape is as it is, whatever the shape here it is. Now if I using the adjacent average, if you notice that the adjacent average, the maxima has changed. Okay, so the maxima changes here. So click on OK. Now you have if you see the object manager, you have one is smooth curves and one is, so if you deselect it, now you say your graph is relatively smooth. So if you want to see the smooth data, the data smoothing data, so these are the smooth data. We will have the one, the smooth data will be created in a new column. So if you see the extreme right column, the COI, so these are the smooth data after the data points after smoothing. So when you will be again you will be plotting it, so you have to use this smooth data for the 2 theta, this 2 theta versus this smooth data. Okay, so if you plot these two, so you see now I have a smooth curves.
You have calculated because smoother you graph. Okay, so that smooth curve, so data points are correspond to that smooth red. Yes. What is your the noise that is there? That is your original data. If you see after smoothing, if you go to your data set at the right column, you have your smooth data. Yeah, but after smoothing,
Sir,
Yes.
sir, please explain the smoothing part. I won't be able to hear you due to network connection.
Okay, so these are my XRD data. So I'm doing it again. Analysis, signal processing, smoothing, open dialog box. So now here, if I select the preview, so this is the graphs here. So if I see the preview here, I still have some noise in the red plot. Red is your smoothed prop. So what I'll do, I'll just increase the number of points. Instead of 5, I'll increase it as 50. So I have relatively smooth curve as compared to previous one, right? So then once you click on OK, then you will have this one, previous. So you'll have the smooth data now. So if I see the plots here, Okay, so say this one is a smooth curve. The after the red one, this is a smooth curve. So you can see if you compare it first, my original data is this. So after smoothings, I have this one. So this is smooth one. So the data points. So if you look into this data points, so you have a data points here, the smooth data curve. So when you redraw your graph, so you have to use these smooth data points. So now is it clear?
Yes, sir. So, but we do not require to redraw it, na? We can just directly take the smooth curve.
Yeah, that you can do it, but if you have multiple data, if you have multiple plots, for example, if you have for 4 samples, so you have to redraw it. Otherwise, the graphs don't look good, and or at least you have to change the color, because every smoothen graphs, the default settings is a red color. So if you have two, three samples, or you are doing it for 2, 3 samples, every graphs will be red color. So you have to do some modification to the graphs before if you don't want to redraw it.
So, sir, is there any option to change the color? Okay, from here
Obvious,
about that.
of course.
Ask.
If you, yeah, if you just tap that, yes, discuss from your color, the broadcast and the shape and all these things, connector and do it if with both types also. Okay.
Sir, sometimes what happened, we draw the graph between L and C by C naught log. So how
So
to smooth such type of graphs?
sorry, Ellen.
For log of C by C naught, for example, in the rate kinetics, we need to draw the graph of
Okay.
concentration. So how to
So do you have
smooth?
if do you have sufficient number of data set? At least you should have at least more than 50 data set, like to get a good smooth curves. You should have higher number of data set.
No, sir. Actually, I take always 1 hour reading. Means in 10 interval of
How
time,
many data set do you have?
I,
How many data
six
set
or
do you have?
seven in a graph, single graph.
That you do, like you just fit it using the spline or something different, such spline or the connectors, because 6 or 7, if you smooth it, there will be error will be there. So if you are talking the reaction kinetics, then if you are fitting it using, if you are smoothing it, so that will give you the amount of error will be huge. As per my knowledge, I think that you should not do it like smoothing your curve for concentrations or finding the rate. So that for fittings, you just change the line from the straight line. You can do it at the spline or B spline.
No, sir. I have to keep my graph straight line because I am drawing the graph between L and it gives straight line. But sometimes the concentration that I'm collecting is going
Okay.
up and down. That creates a problem.
So if it is the straight line, then why should you like the smoothing? There won't be any like smoothing, doing smooth. You can try. I'm not sure that it will give you some suitable results. You can try it. The same methods you can use the same methods, and you can try it. You try, and if you are facing any issues, then just let me know. You try it with the data, the how many whatever the data do you have, just try this with the data to smoothly, and if it is whether it is working or not. Because shape, I think the values that we use different less number of data sets. Okay, just try it, and then if you're having any difficulties, then you can discuss. So if you see the data set now, see the data set here, a data set. If you want to change some values, you won't be able to do it. You try it. For example, if you want to, you won't be able to do it if you want to change the data set. The data, these data sets are locked. Okay, now let's say you want to change it some things that you need to you need to change some things that in right click on the column and click on remove links. So click OK. Now you can change anything, whatever you want. Sorry, one. There might some issues. You can copy and paste it. Kunal, Kunal, lunch break কখন? এখনই? Okay, so we'll have a lunch break and then we'll start again.
Second half mostly will be that other three ones. We had one more modeling, fresh up data, which are very noisy data. So we'll see that and then basis selection, peak finder and area, and after that we'll move to the basic testing.
Sir,
Yes.
I was going through the graph plotting yesterday, and this is the Excel one I have made. Okay, and this one is in origin. Snap the display shift this. The question is given, I cannot find this in Excel. Can you just please- No,
Thank you for joining us
now
for
I'll
this
start
session.
with
Please take refreshment before going, and we will have another session at 2 o'clock. Please be on time.
how did it- So when I try to do this in Excel, 34.
What do you want? You start.